Hello, everyone. My name is Ute Perkins, and I am the interim product manager for the screw chiller products out of Daikin Applied Europe. I'm currently working remote from the United States until travel restrictions are lifted, and then I can return to Italy. Until then, it's good to be visiting you via this web conference. We are pleased to offer this new format for introducing products, technology, stuff like that from Daikin Applied Europe. With this new format, we hope to provide a more behind-the-scenes look into our business with the people and products that make it work. I may be a little biased, but I think this is a great way for Daikin to share our path forward with the rest of the HVAC world. Our topic today will be focused on compressor inverter technology. For this purpose, we've invited Mr. Fabio Liderati, the General Manager of the Power Electronics Division at Daikin Applied Europe. So thank you, Fabio, for being here today.
Thank you, Ute.
As most people know, an inverter is a device that can take an electronic signal input and translate it to a signal output to an electronic motor or change its speed. Of course, there are a lot of other things happening, but in its highest definition, that is kind of what an inverter will do. In my experience, specifically with screw compressors, there have been two basic types of inverter, air-cooled and water-cooled. As we expand from our previous explanation, the operation of the inverter generates a lot of heat that needs to be removed. If that heat is not dissipated, disruption or failure can occur in the inverter. For that reason, there must be a means to cool the device. Again, and in my experience, I typically have seen two types of inverter cooling or heat dissipation, air-cooled and water-cooled. The most commonly cooled inverter is probably the air-cooled type, at least that I have seen. This is just a small fan that will draw or push air across the heated components, dissipating the heat generated. The second type mentioned is the water-cooled type. In this case, a sealed heat exchanger is designed into the inverter that will allow pumped water to gather heat from the heated components and reject it through another heat exchanger in relative close proximity. Think about your vehicle's engine block and radiator. That's how that water-cooled system works. In today's discussion, however, we'll be talking about a third type of inverter cooling using refrigerant. So Fabio, did I miss anything in my description on inverters and introduction into today's topic?
I'd like to add just something, Ute. The inverter is a device that allows to control the speed and the torque of electric motors. This means that we can improve the efficiency of the compressor and therefore the chiller and to reduce the energy consumption.
Perfect, thank you. Now, you lead the Power Electronics Division, which started back in 2018. If I could ask, what led to the start of the project?
From my point of view, Daikin caught some signals from the market, as for example the energy consumption, and has decided to be strategic to have a direct control of inverter technology.
Awesome. So tell me more about your team. How was it for them to become part of the Daikin world? And what are some of the challenges and goals you're facing?
Long story. For more than 20 years, my team and I have worked in power electronics. We work not only for the automation sector, but also in the field of alternative energies. Before joining Daikin, all of us worked in a small and medium-sized company. So now we are proud and enthusiastic to have started a collaboration with a multinational company like Daikin. We can improve our skills about the design and production procedures and deepen the concept of total quality. About the goals, Daikin is the #1 in HVAC market, so we get to design and make inverter for the #1.
Yes, absolutely. That is great. And it's very awesome to have you part of the Daikin team, that's for sure. Now, you are currently developing and leading a new type of inverter-cooled drive. And I mentioned the air-cooled and water-cooled. Tell me about what you're doing there.
The software embedded in our inverters allows to control different types of electric motors, such as asynchronous and synchronous motors. We developed the product to be mounted on the compressor board. The cooling plate of the inverter is cooled down by means of the refrigerant gas. This means space reduction. The traditional air-cooled product would have been very large and impossible to be mounted on the compressor. I can see several benefits in this design. In my past experience, I saw in the air-cooled product a lot of a problem with fans, causing in some cases the replacement of the complete inverter. The water-cooled inverter needs an additive to be mixed to the water in the cooling loop. The additive has to be replaced every few years. The missed replacement can cause big trouble or, in extreme cases, failure. In my opinion, our solution is very reliable.
Absolutely. And you took the words right out of my mouth. I have seen some of those exact same failures and troubles that you were talking about. Now, especially when it comes to the size of the drive. Now, typically with air-cooled drives, the higher ambient temperatures means the higher footprint of the drive. And so that would take up a lot of control cabinet space. So this, to be honest with you, this is fantastic news for me, because that will free up space in my control cabinet when I'm working with engineering to design a chiller to give us more room for other components. That's fantastic.
Thank you. Thank you so much.
Now, can you tell us about the development of that refrigerant-cooled inverter? More importantly, about the process, like when did the project start? How long did it take? How many tests have you performed? That kind of stuff. And then finally, what are the aspects you need to take into account when developing this kind of technology?
Thank you. 2 years ago, we started with the design of inverter size, 330 kilowatt. Now we have a family of a product for screw compressor from 90 to 400 kilowatt. And last year, we started designing inverter equipment for centrifugal compressor. And next summer, we will have a family of solution from 200 kilowatt up to 800 kilowatt. About the attitude need, what can I say? Not only excellent electronics and hardware and software skills are required in our team, we also need mechanical know-how and engineering skills. In addition, teamwork and collaboration with design teams of a compressor and chiller area is crucial.
Wow. Again, I'm just absolutely blown away by this advancement and cannot wait to see it applied in our products. This is very exciting indeed. Now, as you look to the future, what challenges do you anticipate having to overcome?
Well, now we have two important goals. First, to design and realize the low harmonic solution to meet the new needs of market in order to expand our commercial offers. Second, to certificate our inverter according to UL standard for a better collaboration with our Daikin Applies America colleagues.
I like the sound of that. Fabio, this has been absolutely great. Again, I cannot wait to see this applied and in the field quickly. This is really, really exciting news. I think that just about wraps it up. Everybody, I hope you enjoyed our short segment today. I know I did. And I just want to say that in the short time that I have personally been with Daikin in both the United States and Europe, I see the future of HVAC, from products to, more importantly, the people. They have a commitment to quality, innovation, and teamwork. Thank you again, Fabio, for taking the time to share this technology with us today. And all of you out there who tuned in, a big thanks to you as well. From all of us at Daikin Applied, I just want to say stay safe and stay healthy.
Thank you so much.